Hello friends, today we are going to see about another machine learning algorithm, that was logistic regression. This algorithm is an supervised learning algorithm. This kind of ML model is used for binary classification problem, and the output of this model is in a form of categorical. Okay, let's see with an example. For example, we have one data set that contain student study hour and whether and result. If a student study for 2 hours, they will fail in the exam. If the student is spending 3 hours, they fail in the exam. Like that, for 4 hours fail. Like this, the students which are study for more than 5 hours, they will pass in that exam. To to um, to train a model that can take a input of study hours, and depending upon the study hours, they need to provide a output, like whether the student is pass or fail in that exam. To do this, we are using logistic regression, because here the output is in a form of categorical, not in a regression format. Whether the students will be pass or fail. There are two categories. Because of this, there is only two state in this output, so that this problem is called as binary classification problem. Okay, how does this logistic regression will work? We have another question also. Logistic regression, this was an classification problem, but why? Because this classify whether the person is fail or not. This is classification problem. Why this problem is named as regression? We have this doubt. Let's see why this model is called as logistic regression. Because let's consider the data set, and we try to solve this problem using linear regression algorithm. For example, let's plot this. Let's consider when the person is failed the exam, the output will be 0, and if the person is passed the exam, they will get the output will be 1. Let's consider this. Then this output is in the form of zeros and ones, so we can use this data in a regression form. Let's plot this data in a chart. For example, in this example, student study hours is in x-axis, and our result is in this y-axis. Here we having 1 2 3 4 5 6 and 7, and here is 0 and here is 1. Let's consider this. A person who study for 2 hours, they fail in the exam. So for fail we should consider result as 0, so that for 2 hours the data point will be present here, for 3 hours here, and 4 hours here. Whenever a person who study for 5 hours, they will pass. That means we will get 1 as an output for 6 hours and 7 hours. Okay. In a regression problem, we need to find a best fit line that having less error. Okay, whenever you by using this data set, whenever we solve this problem in using a linear regression, we can get a best fit line here, because whenever you whenever you drawing this line in this form to this data set, we can get minimal error. Okay. Okay. Then this person okay. For example, the 0 and 1 in between there is 0.5. If a person who study for less than 5 hours, for example here less than 5 hours, whenever we try to plot, we try to find we will get output as less than 0.5. in a linear regression we will get output as less than 0.5, and whenever we find if a student study for greater than 6 hours, the linear regression output will be greater than 0.5. That means by solving this problem using a linear regression, whenever a student who study for more than 5 hours, they will the output will be more than 0.5, and a person who study less than 5 hours, the output is less than 0.5. Okay, let's consider whenever a person who when the output is greater than 0.5, let's consider this output as 1. Whenever the output is less than 0.5, let's consider the output as 0. By using this condition, we can classify whether the person is fail or not using this linear regression problem. Okay, we can so by seeing this formula, we can make a conclusion that we can solve a logistic problem using regression problem by using this condition, binary classification problem by using this condition, using linear regression algorithm. But what if this data as an outlier? Let's take when a data point as present here. Because of this, the linear regression try to find a line that having minimal error, so that it's try to move the line like this. Okay, because of this outlier, the line is changed a little bit. Now let's compute this algorithm. Okay, whenever a person who using this new line, whenever a person study for 5 hours, let's mark it in this line. Whenever a person is studying for 5 hours, the linear regression output is now less than 0.5. that means less than 0.5 means the person is fail in the exam. Okay, but the real output as whenever a person who study for 5 hours, they should be pass in the exam. But because of this one outlier, the line is deviated somewhere, so that it giving output as in a incorrect form. To solve this problem, the logistic regression is come to place. In logistic regression, we will use logistic regression by, for example, this line is extending after 0 and extending below the 0 and extending after the 1, but we need output, it should be in between 0 to 1, so that whenever the output is less than 0.5, we can consider the output as 0. Whenever the output is more than 0.5, we consider the output as 1. To satisfy this condition, we have to not extend this line, and we did not extend this line towards below. We need to scotch this line like this. Then only we will get output as 0 or 1. So to do this, we apply sigmoid sigmoid function to an linear regression, to the linear regression, like 1 divided by 1 plus epsilon power minus z. Here z represent mx plus b. The mx plus b means this is slope of an this formula is represented a line in a 2D vector space. So after applying a sigmoid function, the sigmoid function to the linear regression, the output will be lies between 0 to 1. Like this, we will scotch this line, so that whenever the input as when the input as less than 3 hours, less than 4 hours, less than 5 hours, our output will be 0. When the input is more than 5 hours, our output will be 1, because by applying a sigmoid function we catch the line between 0 and 1. By doing this, we can classify whether the student is pass or not. Okay. We have by seeing these examples, we have a question in our mind: why we do not use linear regression for a classification problem? Because of these two conditions. Because whenever we use the regression algorithm for a classification, because of outlier, our best fit line will vary or will be affected. And we need to scotch this line. We need to scotch this line in between 0 to 1 to do this two condition. We have to use sigmoid function over the linear regression, so that we can get output between 0 to 1, so that we can easily classify whether the student will pass the exam or not. Okay. For linear regression, there is some matrices to evaluate whether the model is good or not. Like we have already see that MSC, R square, adjustment R square, these matrices are used to check whether the model is perform well or not. Like this, for a regression problem, for an classification problem, there are some matrices like the matrices like the evaluation matrix like accuracy, confusion matrix, precision, recall, and F1 score. These matrices are used for to check whether the classification model perform good or not. Good or not. We already see these matrices in SVM algorithm. I will elaborate it in another video. How this matrices, this evaluation matrices will work for a classification problem. Thank you.